Welcome to Electronics Protection in Aerospace and Defense, where I hope you will gain insight into the contexts in which thermoelectric technology can benefit you. Photographed here is a 14-year-old Tekka model AHP 1200X air conditioner. It was in service for over 120,000 hours before requiring a thorough cleaning. After removal of debris from the hot side, this model could cool reliably once again. When reliability is non-negotiable, when performance over cost is the order of the day, thermoelectric cooling technology is likely the best solution. Thermoelectric air conditioners protect electronics in all environments. Cooling up to a half ton is possible with a single thermoelectric cooler. Thermoelectric cooling technology is uniquely positioned on the thermal management family tree. Thermoelectric enclosure coolers are more compact and technologically advantageous than simpler solutions like fan trays. When compared to vapor cycle cooling, there's less maintenance, lower cost of ownership, and less vibration. Simply put, in mission-critical applications, reliability is king. Thermoelectric cooling is a reliable, long-lasting technology by its very nature, making it an ideal and sometimes the only candidate for certain projects. How does thermoelectric cooling technology work? In a thermoelectric module, heat transfer is achieved by applying electricity to dissimilar semiconductor materials. Extra electrons in N-type semiconductor material and a shortage of electrons in P-type semiconductor material move heat energy from the cold side to the hot side. The main parts of a thermoelectric system are a cold junction, a heat sink, and a low-voltage DC power source. In a nutshell, thermoelectric cooling is a solid-state method of heat transfer, sometimes called the Peltier effect. A thermoelectric cooler has no moving parts other than its fans. It uses no freon, coolants, or compressor, making it safe for the environment. Due to its solid-state nature, it is known to have a long service life. For example, individual thermoelectric modules at room temperature are rated with a mean time between failure of 200,000 to 300,000 hours. At an elevated ambient of 80 degrees C, 100,000 hours mean time between failure has been calculated. Who uses thermoelectric cooling? What kind of applications benefit the most from its use? Typically, engineers and end users who are dealing with the most trying conditions turn to thermoelectric cooling to protect their enclosures. Electronics enclosures in tough environments meet any number of challenges. Humidity, high ambient temperatures, salt spray, blowing sand, ambient dirt and debris, to name a few. Protecting sensitive electronics and sealing them off from contact with dangerous ambient environments is imperative in military, aerospace, medical, laboratory, and industrial applications. To illustrate this, imagine a military vehicle carrying communications equipment into the field. It will likely be exposed to shock, vibration, and harsh elements such as blowing sand. In our example, a thermoelectric air conditioner such as the Tekka model AHP 1200XM is suitable to exposure to all these conditions, utilizing components, design techniques, and military-grade fans on both the hot side and the cold side. This type of air conditioner will maintain its robust integrity during the trip. Once in the field, the end user will be able to set up the communications equipment, turn on the thermoelectric air conditioner to provide protective thermal management, and repeat this process again and again. What other applications might benefit from thermoelectric cooling? Hard-to-access areas such as an industrial plant, crane-mounted electronics, and enclosures along rail lines are a few examples. Consider the urgency of each application, as well as its surrounding environmental conditions.